Imagine this. You're heading out the door for work, running late, and just as you grab your phone, low battery, 1% remaining. You could have sworn you charged it overnight, but somehow it barely made it through. No time to charge now. You'll just plug it in at the office, but then you get to your car, your electric vehicle, and realize you forgot to plug it in. Estimated charge time 1 hour and 45 minutes. Not happening. You check your smartwatch, dead. You try to power on your laptop, it won't last the morning. And just like that, your entire day is crippled. All because of one problem we never seem to solve: batteries. Now imagine this on a much bigger scale. What happens when a hospital loses power because its backup batteries can't last through the night? Or when an entire city faces rolling blackouts because its grid-scale battery storage simply isn't enough? What about electric planes, space travel, deep-sea exploration? The reason we don't have futuristic, unlimited clean energy solutions yet isn't a lack of ideas. It's the limitations of battery technology. Right now there are over 15 billion battery-powered devices on the planet. Smartphones, laptops, medical devices, smartwatches, electric vehicles, satellites, industrial robots, you name it. And at the core of nearly every single one? Lithium-ion batteries. These batteries revolutionized technology when they first became commercially available in the early 1990s. They were smaller, lighter, and longer lasting than their predecessors. And since then, every single one of your devices has been powered by this same basic technology. But here's the problem. Lithium-ion batteries haven't fundamentally changed in over 30 years. Sure, we've made incremental improvements. Your phone lasts a little longer than the flip phones of the early 2000s. Your laptop doesn't die quite as fast as it used to. And electric vehicles can now go hundreds of miles instead of just a few dozen. But at the end of the day, lithium-ion technology is still slow, inefficient, and frustrating. Think about it. Your phone still dies within hours of heavy use. Your laptop's battery life gets worse every year. Your electric car? A full charge still takes much longer than filling up a gas tank. And, worst of all, lithium-ion batteries are prone to overheating, swelling, and even catching fire. We're still working around these problems rather than fixing them. But here's the exciting part. That's about to change. The need for a breakthrough. The world is shifting towards electric everything. Gas-powered cars are being replaced by EVs. Fossil fuels are being phased out for renewables. Our entire power infrastructure is changing. But our batteries, they're not ready for this future. Take electric vehicles, for example. Yes, they're incredible, but their biggest limitation, battery life and charging speed. A Tesla Model S can travel about 400 miles on a single charge. That's impressive. But when you run out, you need hours at a charging station to fill up. Even fast chargers take at least 30 minutes for a meaningful boost. Compare that to a gas-powered car. 5 minutes at a pump and you're back on the road. Until we fix this, EVs will always have a serious disadvantage. And what about renewable energy? Solar and wind power are the future, but they come with a problem. The sun isn't always shining. The wind isn't always blowing. So how do we store massive amounts of energy for when we need it? Lithium-ion batteries aren't cutting it. They degrade too quickly and don't hold enough charge to power an entire city for long. But here's where things get exciting. Scientists are working on radical new battery technologies that could completely change the game. The batteries of the future. Imagine a battery that lasts weeks instead of hours, charges in minutes, not hours, never degrades, never overheats, and never explodes. Sounds impossible, right? Well, it might not be for much longer. Scientists are developing solid-state batteries that replace liquid electrolytes with ceramic layers, making them safer, faster, and longer-lasting than anything we've ever seen. Some researchers are experimenting with graphene batteries, which could potentially charge in seconds. And then there's an even more mind-blowing possibility. A material so rare, so unique, that it could shatter everything we thought we knew about energy storage. Right now, we're standing at the edge of an energy revolution. The end of lithium-ion dominance is coming, and when it does, everything will change, from how we power our devices to how we fuel entire cities. But before we dive into the cutting-edge breakthroughs, here's a question for you. What's the longest your phone has ever lasted on a single charge? Drop your answer in the comments because in a few years, those numbers might sound absolutely ridiculous. And hey, if you love exploring the future of technology, space, and the universe itself, you're in the right place. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free and it helps us grow this community together. So what exactly are these next-generation batteries? What makes them so powerful? And which one could finally replace lithium-ion once and for all? The answer lies in breakthroughs so radical, they might just change the world, forever. For years, scientists and engineers have been searching for the holy grail of battery technology, a power source that's lighter, more efficient, faster to charge, and capable of lasting for decades without degradation. And now, they just might have found it. To understand why these next-generation batteries are such a big deal, let's take a quick dive into how traditional batteries work and why they've hit their limit. A typical lithium-ion battery consists of three key components: a positive electrode, cathode, a negative electrode, anode, and an electrolyte that allows ions to move between them. When you charge the battery, lithium ions travel from the cathode to the anode, storing energy. When you use your device, those ions flow back to the cathode, releasing energy. It sounds simple, but there's a problem. Lithium-ion batteries are inherently unstable. The liquid electrolyte inside them is highly flammable, which is why some devices, like smartphones and laptops, have been known to overheat, swell, and even catch fire. Plus, every time you charge and discharge a lithium-ion battery, the materials inside wear down. Over time, this reduces capacity, which is why your phone battery doesn't last as long after a few years. And then there's charging speed. The reason lithium-ion batteries take so long to charge is because of ion diffusion limits. In other words, it simply takes time for the lithium ions to move back and forth without causing dangerous heat buildup. Trying to speed up the process too much can damage the battery or even cause an explosion. So if we want a battery that charges in minutes instead of hours, lasts years without degrading, and remains completely stable, we need to rethink the entire structure. And that's exactly what scientists have been doing. One of the most promising contenders: solid-state batteries. The solid-state revolution. Instead of using a liquid electrolyte, solid-state batteries use a solid electrolyte, often made from ceramic, glass, or a special polymer. This single change has massive implications. No flammable liquid, no risk of explosion, more compact design, more energy storage in the same space, faster ion transfer, insanely fast charging speeds. Toyota, for example, has been heavily investing in solid-state battery research and claims they're on track to create an electric vehicle that charges from empty to full in just 10 minutes. That's 6 times faster than today's fastest lithium-ion EV chargers. But here's where things get even crazier. Solid-state batteries don't just charge faster, they last significantly longer. While a lithium-ion battery starts degrading after just a few hundred charge cycles, a solid-state battery could last tens of thousands of cycles without noticeable wear. Imagine an electric vehicle battery that outlives the car itself. And it's not just EVs. Imagine a smartphone that needs only one charge per week, or a smartwatch that runs for months without recharging. That future isn't far off. In fact, solid-state batteries are already making their way into high-end medical implants, where reliability and longevity are absolutely critical. But the big question is, when will they reach mass production? While companies like Toyota, Samsung, and QuantumScape are racing to bring solid-state batteries to market, they still face scalability challenges. Manufacturing solid-state batteries requires extreme precision, and mass production techniques are still being refined. But experts predict that by the end of this decade, solid-state batteries could become mainstream, completely replacing lithium-ion in EVs, consumer electronics, and even aerospace applications. But hold on, solid-state batteries aren't the only game-changing technology on the horizon. Because while they offer impressive improvements, Some researchers believe we can do even better. What if we could make a battery that charges in mere seconds, stores 10 times more energy than today's best batteries, never degrades? No. Matter how many times you charge it, this isn't just a dream, it's a real possibility thanks to graphene batteries, the graphene revolution. Graphene is a material so incredibly thin, just one atom thick, that it's considered a miracle. Substance. It's stronger than steel, lighter than air, and conducts electricity faster than anything we've ever discovered. Scientists have found that by incorporating graphene into battery designs, they can create ultracapacitor-like batteries that charge almost instantly. Imagine an electric vehicle that could be fully charged in under a minute. That's what graphene batteries could make possible. Graphene-enhanced batteries are already showing mind-blowing performance in early tests. Some experimental models have shown the ability to charge 100 times faster than lithium-ion batteries, deliver extreme durability, lasting decades instead of years, store far more energy, making batteries smaller and lighter. So why don't we have graphene batteries in our phones and cars right now? The challenge, again, is mass production. Graphene is notoriously difficult and expensive to manufacture at scale. But as breakthroughs in nanotechnology and material science continue, costs are dropping. Some companies are already using graphene-enhanced battery prototypes in electric motorcycles and power tools. And within the next decade, graphene batteries could completely redefine how we store and use energy. But here's where things take an even wilder turn, because there's one more breakthrough that could be even bigger than solid-state and graphene combined. A battery technology so futuristic, so radically different, that it could store energy almost indefinitely, without any degradation. It's called the quantum battery. And if it works, it could make charging completely obsolete. How does a quantum battery work? What makes it so powerful? And could it actually eliminate the need for charging altogether? Imagine a future where charging your devices becomes a thing of the past. Your smartphone? It never dies, no matter how much you use it. Your electric car? It runs for years on a single charge. Planes, spaceships, entire power grids, all fueled by a new kind of battery so efficient, so futuristic, that it could rewrite the laws of energy storage as we know them. Sounds like science fiction, right? But what if I told you it's already being developed? Meet quantum batteries, a radical new technology that could eliminate charging altogether. If successful, this could be the biggest energy breakthrough in human history. To understand why quantum batteries are so revolutionary, we need to think about why traditional batteries lose power in the first place. In conventional batteries, whether it's lithium-ion, solid-state or graphene, the process of storing and releasing energy causes wear and tear over time. The materials inside break down, resistance builds up, and eventually the battery loses its ability to hold a charge. But what if we could store energy in a way that doesn't degrade over time? That's where quantum physics comes in. The mind-bending. Science behind quantum batteries. Quantum batteries rely on a bizarre phenomenon known as quantum superabsorption. Unlike regular batteries, which store energy in chemical reactions, quantum batteries use the principles of quantum mechanics to trap and hold energy at the atomic level. Here's where it gets crazy. Instead of charging one electron at a time, quantum batteries can charge all their electrons simultaneously, a process known as quantum collective behavior. This means that as the battery gets larger, it actually charges exponentially faster. To put this into perspective, imagine you're filling up a swimming pool with a hose. A traditional battery fills one drop at a time, slowly and steadily. But a quantum battery, it fills every drop at once, instantly. This means that quantum batteries have the potential to charge in a fraction of a second, regardless of size, store energy indefinitely without losing power over time, deliver energy with near-perfect efficiency. Researchers have already successfully demonstrated quantum battery concepts in the lab. In 2022, physicists from the University of Adelaide and Institute for Basic Science in South Korea showed that quantum superabsorption is not just theoretical, it actually works in small-scale experiments. And if this technology can be scaled up, it could be a total paradigm shift in how we think about energy. The end of charging? Think about what this could mean for everyday life. Smartphones that never need to be plugged in. Your phone could draw power from ambient energy, staying perpetually charged. No more low battery anxiety ever. Electric vehicles with infinite range. Instead of stopping at charging stations, EVs could use quantum energy harvesting to power themselves indefinitely. Space exploration without limits. Quantum batteries could allow spacecraft to store massive amounts of energy for deep space. Missions without degradation over time. A world without power outages. Quantum batteries could be used to store renewable energy forever, solving one of the biggest problems with wind and solar power. But here's the challenge. While quantum batteries are theoretically possible, scaling them up is incredibly difficult. The quantum effects that make them so powerful are extremely fragile and require highly controlled environments. Right now, quantum batteries only exist in small-scale laboratory settings, and researchers are still trying to figure out how to make them practical for real-world use. But here's the thing. Every major energy breakthrough in history started as an experiment. The first electrical batteries, developed by Alessandro Volta in 1800, were crude stacks of metal plates. The first lithium-ion battery, created in 1985, was barely functional compared to today's standards. Yet within decades, both became world-changing technologies. And now, with quantum batteries, we might be on the verge of the biggest leap forward yet. Some researchers believe that within the next 20 to 30 years, we could see the first practical quantum energy storage devices. Others think the timeline could be even faster, depending on breakthroughs in quantum computing and nanotechnology. But one thing is certain, if quantum batteries become a reality, they won't just change how we use energy. They'll change everything, and this brings us to the final, most important question. Which of these new battery technologies will win the race? Will solid-state batteries take over first, revolutionizing EVs and consumer tech? Will graphene batteries unlock ultra-fast charging in the next decade? Or will quantum batteries leapfrog them all, bringing us a future where charging becomes obsolete? We are standing at the edge of an energy revolution. For over a century, battery technology has followed an incremental path. Small improvements here, minor efficiency gains there. But today, we are no longer talking about small changes. We are talking about a fundamental transformation, one that could reshape our world just as profoundly as the invention of electricity itself. But the big question is, which of these next-generation batteries will define the future? Let's take a step back and examine where each technology stands today and what challenges remain before they become mainstream. The race to the future solid-state batteries are the closest to large-scale adoption. Major companies like Toyota, Samsung, and QuantumScape are already deep into research and development. If all goes well, we could see solid-state electric vehicles hitting the roads by 2030, with consumer electronics following soon after. But the challenge? Scaling up production. Manufacturing solid-state batteries requires ultra-precise fabrication techniques, and right now production costs are still too high for mass-market adoption. But let's say we overcome these challenges. Imagine what this means for the world. Electric cars that charge in minutes instead of hours. Phones that last days on a single charge. Renewable energy storage that finally makes solar and wind power fully reliable. If solid-state technology lives up to its promise, lithium-ion batteries will become obsolete, and charging anxiety? A thing of the past. But then there's graphene batteries, which could be an even bigger leap. Graphene-enhanced batteries are already being tested in high performance applications, and their ability to charge 100 times faster than lithium-ion could be a game-changer. But graphene is extremely difficult to produce at scale, and we are still years away from making it affordable enough for everyday use. Yet if we crack the code, electric vehicles could charge in under a minute. Drones, medical devices, and wearables could run for weeks without recharging. And for high-power applications like military and aerospace, graphene batteries could push the boundaries of what's possible. And finally, the holy grail, quantum batteries. Unlike solid-state and graphene, quantum batteries don't just improve energy storage, they could eliminate the need for charging altogether. But right now, quantum energy storage is still in the experimental phase. Scientists are proving the concept works in controlled lab conditions, but we are decades away from seeing quantum batteries in practical applications. Yet, history has shown us that breakthroughs happen faster than we expect. If someone had told you in the 1980s that we'd one day have supercomputers in our pockets, capable of streaming live video to millions of people around the world, it would have sounded like science fiction. But here we are. And that's the most exciting part about the future of battery technology. We are only just beginning. The bigger picture. What this means for the world. This isn't just about making better smartphones or faster charging cars. It's about how energy itself is stored and distributed across the planet. Renewable energy revolution. Today, one of the biggest problems with solar and wind energy is storage. The sun doesn't always shine, and the wind doesn't always blow. But imagine a world where we can store limitless renewable energy with zero degradation. No more fossil fuels, no more power outages, just clean, endless energy for everyone. The end of the gasoline era. The moment we have a battery that can charge an EV in seconds or last for millions of miles, the gasoline-powered car becomes a relic of the past. The oil industry, it could collapse overnight. Space exploration like never before. One of the biggest challenges in space travel is power. Right now, deep space probes rely on radioactive generators because batteries degrade too quickly. But a quantum battery? It could power a spacecraft for centuries, making interstellar exploration a reality. The impact of these breakthroughs will ripple through every industry, from healthcare to robotics, from artificial intelligence to climate change solutions. And it all comes down to which technology reaches mass adoption first. So, what happens next? The race is on. Right now, companies and governments are pouring billions of dollars into research and development. In the next 5 to 10 years, we will likely see solid-state batteries replacing lithium-ion in electric vehicles. In 10 to 20 years, graphene could take over, making ultra-fast charging a reality. And in 30 years or less, quantum batteries could change energy storage forever. But what do you think? Which technology do you believe will win the race? Do you think quantum batteries will ever become reality? Or will solid-state and graphene batteries be the future? Let's talk about it in the comments. And if you found this deep dive fascinating, don't forget to like and share this video, so more people can join the conversation. Because the future of energy, it's happening right now, and we are all part of it.